All right, lesson 9.5 is on hyperbolas. And before we get started on this, there's a couple things that I wanted to do. First of all, I wanted to just tell you what a hyperbola is. Basically, a hyperbola is a simple version of two parabolas that go in they approach each other, and then they quickly turn. This one the same way, it quickly approaches it and then it turns. This is just some pictures of some hyperbolas used in real life. But before we start, I wanted to review an ellipse with you real quick on how to write an equation. And if you remember, the equation to write an ellipse was x squared over a squared plus y squared over b squared, and it had to equal 1. And all we did, since this one's in the x spot, remember all we did was square it. So 4 squared is 16 plus, and since this is in the y spot, it goes underneath the y squared, and negative 12 squared would be 144, and then it just equals 1. Okay? When we go to graph the equations, remember that there was a vertex and a co-vertex, but really all we had to be concerned about was taking the square root of 9, which gives us a positive or negative 3, and since it's under the x squared, then it's going to be negative 3, 0. And we plot those points. 1, 2, 3, the negative, and we do the positive. Do the exact same thing, but in this time, since it's underneath the y, we're going to be plus or minus 4. So 1, 2, 3, 4. 1, 2, 3, 4. And then the ellipse just encompasses that, okay? And if they're really close like that, then it could look like a circle, okay? All right, so this is what a hyperbola is, and let's cover a few of the, vocabulary to make sure that we've got everything covered. First of all, the focus, just like on the parabola, is going to be inside the two hyperbolas, okay? The vertex is that maximum or minimum point that we talked about. The transverse axis is basically the line. It's like the axis of symmetry that actually splits it into two. And then asymptotes. Remember when we talked about asymptotes? It's all those dotted lines, and it's basically the graph it's the line that the graph approaches, but it doesn't necessarily cross. Okay. Now, just like when we did this, ellipse, or we've done parabolas. These things can actually lay up and down like this, or we can turn them and they can lay sideways. Okay? All right. The way that we're going to tell how they lay is by their formula. Now, one thing you'll notice about a formula, these look very, very close to an ellipse, the formula. The only difference is these have a subtraction sign, okay? And they're going to alternate depending on how the equation, depending on how the graph lies. So if it's x squared, then that's one where the vertices are actually going to be on the x-axis. Okay? So really all we have to do is, when we're doing these, the vertices, since the x squared term is first, then our vertice is going to be the plus or minus a 0. Okay? So we're going to take the square root just like we did on an ellipse. On this one, since the y squared term is first, then our vertice is going to be on the y spot, and this is one that's going to open up and down. Okay, the foci, okay, there's two. C squared equals a squared. This time it's b squared. Okay, so make sure you have that information down because we're going to really need it. Okay, all right. So let's go ahead and look at example number 1, and we want to graph the equation x squared over 9 minus y squared over 4 equals 1. Well, we've already got our equals 1, and we have a minus. So this automatically tells me this is going to be a hyperbola. Okay, because of the minus sign. Okay. Now, what you're actually going to do is we're actually going to find the square root of both of these. So since it's under the x squared, it's plus or minus 3, 0. Okay? And this is our vertices. Okay? This is where our vertices are at. Okay? Then we want to actually do the same thing. And the reason we want to go ahead and do the same thing, and we're going to plot those 4 points. Okay? So on the x-axis, 1, 2, 3, just like we've been doing. Okay? 1, 2, 3. Okay? And then we're going to do 2. And the reason I want you to do this, because after you do this, we're going to draw a box. And the box is going to encompass, we're going to draw a box. So we're basically going to draw this one. We're going to draw across here so we intersect where we drew our lines. And after you draw the box, and I would suggest using a straight edge, your asymptote is actually, let me see if I can get a tool out here so I can actually, let's just use this one. So your asymptote is going to be when we, and we want these to be a dotted line. So, because I want to be able to make sure and get the exact correct slope of this. Okay, so let me stretch this thing on out. So we're going to draw it from inbox to inbox. Okay, corner to corner basically. So let's go ahead and do the next one. So let's go this way. And then we're going to draw it clear across there. So let's pick it up. And we're just going to extend it. Okay, all right, great. So that basically, the purpose of that is it's going to give me my asymptotes. So right here, the only last thing I have to do is this point here and this point here actually tell me those are my vertices. And so my graph, because they're on the x-axis, is going to look, my parabolas are going to look like this. You just basically make a sideways U and make them approach those asymptotes. Okay? So let's look at the next example. Okay? Next example is we've got to take the square root of this, but because the y is first, then it's going to be in the y spot, and these are our vertices. And then we take the square root of 25, so it's plus or minus 5, 0, and we're going to plot those points on the graph. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. And we go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we're going to draw a box to include all of our points. Okay? So let's go ahead and put in our asymptotes. And then remember, our vertices are on the y-axis. So this is remember, this is a vertex, and change the color here. This one's a vertex, and this one's a vertex. So it's going to approach that asymptote just like that. And we got to do the bottom one. Okay. All right. So the next two examples are U-tries. So go ahead and try those. So go ahead and do these. Pause the video at this time and go ahead and try these two real quick. All right. So when you're all said and done, this is the two answers that you should have come up with. Okay? Because remember, our x squared is first, so it's got to go on the x-axis, and our y squared is first, so it should have went on the y-axis. So, all right. So when we go to write an equation, remember the big thing is, since this thing is a hyperbola, it's got to have a minus sign in it. Okay? And the other thing is, since our vertices are in the y spot, that tells us we've got to use this equation. So we can actually go ahead and fill this thing out. Y squared over 3 squared is 9. It's got to be a minus. X squared equals 1. And we just got to figure out what goes under that x squared. In other words, what our b is. So you're going to use your foci to find that. Okay? Well, our foci is c squared. Our foci is c. So we're just going to take 5 squared equals our a squared, remember 3 squared is 9, plus b squared. So 5 squared is 25 equals 9 plus b squared minus the 9. So you find out that your b squared is 16. Okay? So it's going to go under the x squared. Okay? So looking at the last example that we come to, the first thing you've got to decide is, yep, it's a hyperbola, so I need the one with the minus. My vertices are in the x spot, so then I need this equation. So I got x squared, remember 7 squared is 49, minus, and I just got to figure out what goes underneath the y squared. So my c is 8, a is 7, plus b squared. Oops, those are supposed to be squared. So I get 64 equals 49 plus b squared. And remember, we're putting b squared under the y, so there's no point. 64 minus 49 is 15 equals b squared. There's no point in finding what the square root of b squared is, or what the square root of 15 is, because we want b squared in there. And so that would be your answer. Okay. So go ahead and do the practice problems that's provided and some of the quick checks.